4x minus 6. Obviously, you have your Desmos app, so if we go to our Desmos app, turn these ones off, could go to a new one, and I could type in y equals 2x squared plus 4x minus 6. And we get this graph. So the question is, if we didn't have Desmos, or if we didn't have our graphing calculator, how would we get this picture? And how are we going to find out where the vertex is? So one of the things that we can do is we want to graph this. We've cheated already and saw what it looked like, so we can set our scale a little bit. But we can always plug in values. And a number that's very easy to plug in, it's a nice starting point, is 0. Because that's really easy mental math. 0 plus 0 minus 6 would be minus 6. And we can go to our graph and label 0 minus 6. And since we know it's a parabola, we know that it's U-shaped, and we know that it's symmetrical. Okay? Now, most students would, what do you think most students choose after they choose 0? They would choose 1, right? Copy. They would choose 1. Plug in 1, they get 2 plus 4 is 6 minus 6, they get 0. So they go to their graph. And you label 1, 0. There we go. I just made a new pen. My new pen that I made in blue ink, when I write with it, it goes away after a while. So I hope that you can see, with these two dots, we already know that the graph looks like this as a parabola, but can you see that through those two dots, it also could have been like this? But we do know that it is connected between those two. Lay my pen down, because that's not work that we want to have. It should disappear after a little bit. We don't draw that in. All we do know is that it will be connected between those 2 points. How do I find out which way it's going? I could plug in another point. What do you think students would plug in next after 1? 2, probably 2. If you plugged in 2, you're going to get 4 times 2 is 8, plus 8 is 16, minus 6 is 10. So now I have the point way up here at 2, 10. And at this moment, I should start to think it should swing around the other way. So I would try going in the other direction this time, -1. Plugging in -1 into the equation would give me 2 minus 4, give me -2 minus 6, -8. But I still haven't got symmetry yet. Everything is off. What you really want to find is eventually, and we're going to find it once we plug in -2 here. When I plug in -2, I'm going to get 8 minus 8 minus 6. I'm going to get -6 again. And I'm just going to point out that provides some symmetry. That's where another point is exactly opposite. So I have -2, -6. These are symmetrical. That means my axis of symmetry has to be right in between those two, which happens to be at x equals -1. Can you see from this that if this one is 2 away from my axis of symmetry, I would also have one right here, 2 away from my axis of symmetry. And if I went up to the other point I found, 2 is 3 away, right? That's 3 units away from my axis of symmetry. If I went 3 units in the other direction, I would get to -4. I'd have -4 coming. And so knowing that a parabola has some characteristics, symmetry, axis of symmetry, it's U-shaped. If you do a table of values, and once you find the symmetry, you're going to be able to draw the graph. And now we can talk about characteristics. Parabolas have x-intercepts and y-intercepts. Can you see that the y-intercept is at -6? And you can either write it as -6 or you can write it as the coordinate. And the x-intercepts, there's 2 of them. There's one at -3, 0, and there's another one at 1, 0. And again, you could either write them as coordinates or write them just as x equals -3 and x equals 1. Both of those would be fine. The coordinates of your vertex, -1, -8. The equation of the axis of symmetry, always x equals, and it will be x equals -1. The domain is always everything for a parabola. But the range are your y values, and the way that I like to think about figuring out range and domain is, do I have a smallest y value? The answer to that is yes. Smallest y value is -8. Do I have a biggest y value? No, it goes up forever. How do I write that the y values are always going to be bigger than or equal to -8? I write it as y is greater than or equal to -8. That would be one way to write it. This is called set notation. In grade 10, did you learn integral notation as well? That another way to write this would be, it starts at -8, it goes up forever to infinity. We include -8, so we use a square bracket. Infinity always has a round bracket. Have you seen that notation before? So you can choose whether to have the notation with the greater than or less than sign, or to write it as an interval. Okay, so I'm going to get you to circle 4, 5, and 7. No, that's something else. So round bracket means not included. In French immersion, you would have had it as a backward square bracket, if you remember. Yeah, something's a little bit different there from the French immersion. Okay. So I'm just gonna get you to circle those for now. No, I won't right now. But I'll remind you to try to switch it. So I want you to look on page 253, and I want you to highlight this. This is the connection between the last unit and this unit. That if you want to find your x-intercepts, you can do that, right? And maybe we find x-intercepts, plug in 0 for y. That's always how you find an x-intercept, because if you think about the point on your graph, the y-coordinate of an x-intercept is always 0. So algebraically, if you want to find an x-intercept, you plug in 0 for y. Okay? So we look at an equation that we have, we plug in 0 for y, and now it's solving just like chapter 3. How can you solve this? Well, we have options. You can factor. Factoring is often the fastest, but doesn't always work. You can complete the square, or you can use the quadratic formula. So those were the 3 techniques that we learned in chapter 3 for solving an equation. Now we can use those in chapter 4 as a way to find the x-intercepts. Okay? So, if I had this, I would probably divide everything by 2 to make it easier to factor. Once I have x squared plus 3x minus 10, it factors nicely to x plus 5x minus 2. So our x-intercepts are 5 and negative 2. And this is where, off to the side, I would like you to write the following things all mean the same thing, but are used in different contexts. So we just talked about x-intercepts. Sometimes they're called zeros. Okay, you can highlight that at the bottom here. The x-intercepts of a graph are called zeros. So sometimes the question is going to say, find the x-intercepts. Sometimes the question is going to say, find the zeros. Sometimes the question, when it's a quadratic equation and you're solving, they're going to use the word, find the solutions. And sometimes, and this is also related to chapter 3, what was another word that we called the solutions? And we used that word a lot when we talked about the discriminant. The discriminant told you if you had 0 solutions, 1 solution, or 2 solutions, but I didn't use the word solutions, right? We used the word roots. Crazy. This is where, sometimes I'm like, come on, man. It would be so much nicer if we just decided on one word and just use that word over and over again, right? Like if we just called, but I think they have the different words because if you were solving an equation, right? Would it feel weird if the question said, find the x-intercept, x plus 3 equals 0? You'd be like, what? But if they say find the solution, you're like, oh, I'm okay. So we use different words because we have different situations where it makes sense to use those words. The reason you use roots is because how do you get rid of a squared? You square root, so we call the answer a root. So we have all of these different words for different reasons, but it's nice to sometimes make a list and say, these are all the same things. They're just used in different situations. And so if I know that x-intercepts are the same as solutions or zeros, it clues me in that I have to plug in 0 for y, because the 0 part is why it's called a 0. And then I'm like, oh, then I can solve that so I can find its roots. All right, that's a good place to end video number 1.